Okay, hi everyone. In this video, we will be looking at AMF Chapter 4, Polynomials and Partial Fractions, Worksheet 1. Okay, so we are going to start in this new chapter to understand in this worksheet what exactly is a polynomial, how can we combine by addition or subtracting or multiplying polynomials, and how do we find unknowns in identities, and also to how do we use the division algorithm. Okay, so let's start. We're going to learn this new definition here today. This thing called polynomials. So, what exactly is a polynomial? This you can read this over here. This is maybe it might be a bit more complicated for you to understand what this actually means. But very simply, what is polynomials is essentially a combination of terms that have x with whereby your power here let me highlight this your power here and x terms terms right with x whereby your power is a non-negative integer. So for example, non-negative means integer examples are 0, 1, 2, 3, 4 all the way. Okay, these are examples of non-negative integers. Okay, and then all these x terms are multiplied with a coefficient. We have learned this in lower sec, this term called coefficient. So for example, let's say if I were to look at for example, consider one simple example. Let's say if I have 2x squared. Okay, this is also considered a polynomial. Okay, the 2 here is a coefficient, and the power here is 2, which is the power for polynomials is always a non-negative integer. Okay, and we're going to introduce this important thing called degree now. What is a degree? It is the highest power of x in the polynomial. So for example, if let's look at this qx here, defined by x 4x power 3 minus 5x squared plus 2. The degree of the polynomial is the highest power of x. So if I were to look at this polynomial over here, the highest power is x power 3. So therefore, this polynomial, the degree is 3. Okay, that's simply what degree means, the highest power of x. So let's look at some simple examples. Let's say if I want to look at a polynomial of degree 5, it can be any polynomial. Let's say if I were to 4x power 5, this itself is a polynomial. I can add different things as well. Let's say if I want to add plus 4x power 3, this is also a polynomial of degree 5. If I were to add, let's say, minus 5, this is still a polynomial because of degree 5 because all the powers and the powers here are non-negative integers. Okay, if you can imagine over here, 5, even though there is no x here for 5, but it's actually an invisible x power 0. And you learn in the chapter of indices, x power 0 is equal to 1. So constants, just numbers by itself, are also polynomials with an invisible x power 0. Okay, so this is an example of a polynomial with degree 5. Let's say degree 3. You just need to write any polynomial with a highest power of x to be degree to be of 3. So let's say if I put negative 2x power 3, this is also okay. You can add terms like plus 2x plus 1. For example, this is a polynomial of degree 3 because the highest power of x is 3. Okay, then the last one is a constant polynomial, meaning that the constant polynomial means your degree of the polynomial is 0, and we as mentioned earlier, x power 0 is equal to 1. So polynomials that are constants are just numbers. It can be, let's say, negative 3, for example. This is a constant polynomial. The degree is 0 because this is an invisible x power 0. Okay, so this is what we mean by constant polynomial. So let's look at example 1. Example 1, determine if each of the following is a polynomial or not. Okay, so let's simply look at it. Let's look at part A. Negative 9, is this a polynomial? Okay, I hope you can recognize that it is a constant polynomial. This is an invisible x power 0. Negative 9x power 0, which is equal to negative 9. So therefore, this is a polynomial. Next one, if I have 1b over here, negative 3x squared plus 2 root x. Root x, I hope you can recognize, square root x can be written as x power half. Okay, if we were to go back to the definition of polynomial, as mentioned earlier, the power must be a non-negative integer. Half is not an integer, so therefore b is not an integer. B is not a polynomial. Let's look at part C. Part C, I look at this expression here. I note that all the powers are non-negative integers. This is a 1. Okay. Then the coefficients here can be any number. It can also be a non-integer. It can be a decimal. These are considered polynomials. So therefore, C is a polynomial. Okay. If I will look at part D now, if I were to rewrite part D, 4x cubed, 4 over x squared, this can be rewritten as plus 4x power negative 2 minus 7. And then we check this power here negative 2, therefore it is not a non-negative number. This is a negative number, so therefore D is not a polynomial. And for part E over here, okay, we note that E over here, this whole thing inside is a this whole thing over here is a polynomial, but when I take square root of this entire polynomial, it is not a polynomial anymore. Okay, so let's answer the question. I know that for this question here, A and C are polynomials. Okay, and I know that from here, B, D, and E are not polynomials. Okay, I hope that you can see why they are not polynomials given by the definition over here, whereby the powers should be non-negative integers. Okay. Okay, and then for part D over here, part E over here, this is a square root of a polynomial. Square root of a polynomial, which is not a polynomial. Okay, so with that, I hope you are now familiar with what is the term called, what is a polynomial. We will now start to learn what are the things we can do with polynomials. So now let's look at the next page, page number 2. Okay, now we will learn how do we add or subtract polynomials. So it is very similar to how you add quadratic expressions, etc. Let's say if I have two polynomials defined as px equals to 2x cubed minus 3. Okay. Then the next one, I define qx to be 4x minus 1. So 2 times of px plus qx is simply equals to, so let's write out part A. Okay, 2 times of px plus qx, this is simply equals to 2 times 2x cubed minus 3, then plus 4x minus 1. Then I were to expand and simplify, I'll get 4x cubed minus 6 plus 4x minus 1. Therefore, final answer, 4x cubed plus 4x minus 7. Okay, and this is for example 1. Example 2a. Okay, then next part, example 2b, simply px minus 2qx. You can work it out by yourself. Combine all the like terms together. So over here, px is 2x cubed minus 3, then minus away 2 times of 4x minus 1. Okay, so if I were to expand and simplify, I'll get 2x cubed minus 3 minus 8x plus 2. Final answer, 2x cubed minus 8x, then negative 3 plus 2 is minus 1. Okay, and therefore you have your answers for part A and part B. Okay. So now if we were to look at these solutions over here, when I add these two polynomials together or subtract them, my final answer here is still a polynomial. So therefore, we can observe that the result, whether when I add or subtract two polynomials, the result is still a polynomial. Okay, this is for example 2. Okay. Next one, let's look at example 3 now. Now I want to see how do I multiply polynomials together. So let's look at example 3. This is similar to what we have done in Sec 2 math. So over here, let's look at example 3a. Okay, example 3a, I have 3x minus 2 times x squared minus 7x plus 5. We can apply the distributive law. So like what you have learned in Sec 2, this is equal to, I take the first term, 3x, multiply to each term 1 by 1. So first step, 3x times x squared, which will give me 3x cubed. Then next one, 3x times negative 7x. Okay, this will give me minus 21x squared. Then the last one, 3x times 5. Okay, this will give me 15x. Okay, then the next one over here, I have negative 2 now. Now negative 2, we apply the distributive law. We'll multiply it to each term in the other bracket step by step. So negative 2 times x squared will give me minus 2x squared. Then next one, negative 2 times negative 7x will give me positive plus 14x. Then the last one, negative 2 times 5. I will get minus 10. Okay. Then now I simplify, combine all the like terms together. So let me highlight all my like terms. Negative 21x squared. This is a like term with negative 2x squared. Okay, so therefore, combine together, 3x cubed, negative 21 minus 2, I'll get minus 23x squared. Then next like term, I have 15x over here and 14x. So therefore, combine these two together, I will get plus 29x minus 10. Okay, very simply, so this is therefore my answer for part A. And for part B, steps are the same. You can now try by yourself if you want. Okay, over here, I have x cubed minus 2x plus 5 times 3x squared plus 4x minus 5. Okay. So very simply over here, you can just expand out step by step. Okay, so over here, I do it term by term. X cubed, okay, times 3x squared, then x cubed times 4x, then x cubed times negative 5x, x cubed times negative 5. Expand out, do it step by step, don't make careless mistakes. I'll get 3x power 5 plus 4x power 4 minus 5x cubed. Then now do it step by step. Negative 2x now will multiply to 3x, 4x, 3x squared, 4x, and negative 5. Okay, and I'll get minus 6x cubed minus 8x squared plus 10x. Then now the last one over here, 5 will multiply to 3x squared, 4x, and negative 5. Okay, so if you do it step by step, don't make careless mistakes, you should get the correct answer from here. Plus 15x squared plus 20x minus 25. Okay. Then from here, all you need to do now is to combine all the like terms together. 3x power 5. I now look at the terms that have x power 4. I have only one term with x power 4, so plus 4x power 4. Then now look at the terms with x power 3. I have, let me make this bigger. Negative 5x cubed minus 6x cubed. This all, so therefore this will give me minus 11x power 3. Next one, look at terms containing x squared. I have 8x, negative 8x squared plus 15x squared. I will get plus 7x squared. Then last one, 10x plus 20x, I'll get plus 30x minus 25. Okay, and this is the answer to example 3, using the distributive law. Okay, method 2 I won't be going through. You can check, this is similar to what you did in primary school when you multiply numbers together. But I would prefer using this method because I feel that it's clearer. So, but you can read through here if you want to try. I would prefer method 1, that is, it feels much clearer to not make careless mistakes. Okay. Alright, so now let's look at example 4 now. Okay, example 4. The question now says, find the coefficient of x squared in this expansion over here. So if you think about it, right, do you need to multiply everything term by term? Multiply everything term by term, then after that go and simplify everything just to find your x squared term over here? You can do that, but that is not the best move. Because you need, as A-math students, you need to find much smarter ways to solve the questions in a much faster method. So over here, we have to analyze this expansion here. if I want to find the coefficient of x squared, all I need to do is to consider the terms. When I expand out, this term will multiply here, here, here. This term here will multiply here, here, here. I just need to find among all these expansion and product, which one will give me an x squared term. So to analyze, right, I look at x cubed. No way that x cubed can multiply to anything to give me an x squared term. So this is out. But if I were to look at negative 3x squared, oh, my highlighter too big, yeah. Negative 3x squared, if this term here multiply to negative 3, I will get an x squared term. Okay, x squared term. Then next one, I look at the next one over here. If I have negative x over here, I can only multiply this to 2x in order to get an x squared term. And the last one, I have 1 over here. This one can only multiply to x squared in order to get an x squared term. So therefore, all I need to do is to multiply these three things together. 1, 2 is this one here, multiply together, and multiply this together in order to find my x squared term. Okay, so therefore over here, the term is simply negative 3x squared times negative 3 plus next one. So this is the first one that is done. Okay, next one, negative x times 2x plus negative x times 2x. Then the last one, plus 1 times x squared. Okay, and therefore if I were to simplify this, I'll get 9x squared plus, oh no, minus away 2x squared plus x squared. Combine everything together, I should get 9 minus 2 plus 1, 8x squared. Okay, therefore I haven't answered the question yet. The question says, find the coefficient. If you still remember what is definition of coefficient, the number multiplied to your x, to your variable over here. So over here, therefore, answer the question. Therefore, the coefficient of x squared is 8. And that is the answer to example 4. Okay. Okay, so let's move on now. So over here, you can just write a big no. Do not make such silly mistakes, or if you want, you can, but as long as you don't make any careless mistakes. So if you are able to, you can do it step by step to see easily how do I get the x squared term without expanding out every single term over here. Okay. Alright, so now let's look at the next part over here. Now we're going to look at this thing called identities. What is an identity? So let's look at this equation over here. Let me highlight this. Okay, this equation, if I were to look at this equation, right, this equation only holds true when I sub x equals to negative 1. Let's say if I sub x equals to negative 1, this will be 1 minus 2, which will give me negative 1 on the left side. Then here sub in negative 1, this will be negative 4 plus 3, I'll get negative 1. So this will be true. And this also holds true if x is equal to 3. Okay, so therefore, this is an equation. However, the next equation over here, x squared plus 2x, I factorize out the x, right? I'll get this over here. This equation is true for all values of x, meaning that if I sub in, let me highlight this, for all values of x, meaning that no matter what x value you sub in over here, this equation will hold true. I'll give you a simple example. Let's say, e.g. over here, x squared plus 2x equals to x times x plus 2. Okay, let's say I sub x equals to 1. I'll get 1 squared plus 2 equals to 1 times 3. Then this will hold true. Because this left side here is 3. Right side here is equal to 3. Okay. Okay, maybe this is not the best way to present. I'll write it as maybe left hand side over here. Left hand side equals to 1 square. Left hand side is LHS means left hand side. So over here 1 square plus 2 times 1 equals to 3. Right hand side equals to 1 times 1 plus 2, which is also equals to 3. Therefore, this holds true. Okay. Next, if I sub x equals to, let's say, any random number. Let's say if I choose 10. Okay. I have left hand side here equals to 10 square plus 2 times 10, which will give me 100 plus 20 equals to 120. Right hand side will be equals to 10 times 10 plus 2, which is 10 times 12, 120. You see that for no matter what x number that I choose, the left hand side over here will always be equals to the right hand side, no matter what x value I sub in. This is called an identity. Okay, so I hope that you are better able to understand. No matter what x value you use for an identity, the left hand side will always be equals to the right hand side, no matter what x value you sub into this identity here. Okay, so usually we can write using this 3-line symbol, but usually use the 2 lines for now. Okay, so let's go into example 5 first, so we can better illustrate what this means. Okay, so let's look at example 5 now. Example 5, I have this this equation here, and the question here says this holds true, left side is equal to right side for all values of x, meaning that no matter what x value you sub into this equation here, the left side is always equal to the right side. This is what we call an identity. Okay, so let's there are different ways to solve this kind of question. So let's first one, substitution or elimination. I want to find out the value of a, b, c. So can you think logically, right? If this thing is equal to this thing over here on the right side, what value of x can I sub in to find out the value of a, b, and c? So let's think about it logically. If I want to find out what is c, I should choose one value of x to sub inside here, such that the a will disappear and the b will disappear. What number do you think I can sub in for this a and b to disappear? That since over here b is x minus 1, right? What should I sub in my x value such that this b here will become b times 0, which will become 0. I hope that you can see that I should sub x equals to 1. Of course, when I do that, let's see what happens. Okay, when I sub x equals to 1, I'll get 5 times 1 square minus 7 times 1 plus 3. This is equal to a times 1 minus 1 times 1 minus 2 plus b times 1 minus 1 plus c. Okay, let me move this to the left a bit. Then we analyze, what is 1 times 1? 1 minus 1 is 0. So anything times 0 is equal to 0. So therefore, this will be simply 5 minus 7 plus 3. This whole thing here will become 0, because this is a times 0 times negative 1. Here will become 0 also. So therefore, I will have just the right side will just be equals to c. Therefore, c will be simply equals to 5 minus 7 plus 3. C is equal to 1. Okay? Then next one. Now I want to find, let's say if I want to find out what is, let's say b. A has x minus 1 and x minus 2, right? I already found out what is c. What x value can I sub in to get rid of a? I have used 1. Now I can sub in x equals to 2. So let's see what will happen. Sub x equals to 2. I will get 5 times 2 square minus 7 times 2 plus 3. This whole thing is equal to, if I sub in x equals to 2, here, this x will become 2 minus 2 equals 0. This whole thing will disappear. I'm left with b, this thing over here, which is b times 2 minus 1 plus c, which is 1. Therefore, I do it step by step and I evaluate out 5 times 2 square, which is 20, minus 14 plus 3 equals to b plus 1. So therefore, if you evaluate it out step by step, b will be equals to 6 plus 3, 9 minus 1, 8. Okay. And now that I found b and c, the last one, you can just submit any x number to find out what is your a value. So let's use small numbers so that it's easier to calculate. Maybe I'll use sub x equals to 0. Okay. Then I'll get, let's observe over here, 5 times 0 square minus 7 times 0 plus 3 equals to a times 0 minus 1 times 0 minus 2 plus b is now 8 times 0 minus 1 plus c, which is 1. Therefore, I work it out step by step. I notice that left side, any number times 0 is 0. Negative times 7 times 0 is still 0. I'll have 3 equals to This is a times negative 1 times negative 2 plus 8 times negative 1 plus 1. I'll get, let's say, 3 equals to 2a minus 8 plus 1. Therefore, 2a is simply equals to negative 7, 10. Okay, therefore, over here, I'll get a will be equals to 5. And therefore, we have solved the question to find the value of a, b, and c. This is using substitution and elimination to get rid of the letters one by one. Okay. Another way that you can do this is using comparing coefficients. So what does that mean? So let's say, right, I have this right side over here. Maybe to make it clearer, what I can do is I rewrite this. 5x squared minus 7x plus 3. This whole thing is equal to a. I combine x minus 1 and x minus 2 together. I expand out this thing, I'll get x squared minus 3x plus 2, then plus b times x minus 1 plus c. So what does comparing coefficient mean? We will kind of think of how do I expand out everything, then I compare with the left side over here. Okay, so over here, don't need to expand out everything because it may get very long. All I need to do is observe. If I were to observe the right side over here, you notice that there is only one term with x squared. If I were to expand this a out into these brackets over here, I will only have one term with x squared, which means that x squared term on the right side will be, let me write out, x squared term on the right hand side will be simply ax squared. Okay, by observation, I hope that you can see that. By expansion, the x squared term on the right side will be ax squared. Okay, there is no other expansion because there is no more other x squared term over here. And if we compare to the left side over here, if the left side, the x squared term, the coefficient is 5, therefore this means that a must be equal to 5. Okay? Okay, so let's now look at the next one. If I were to look at the x term, okay, over here, if I were to look at the x term on the right hand side, let me write out over here, x term on the right hand side, this is simply equals to this a here multiplied to negative 3x to get an x term plus b multiplied to this x. This is the only way I can get an x term. So therefore, the x term will be simply negative 3ax plus bx. Okay? Negative 3ax plus bx. Okay, so therefore from here, what we will see is that if I were to compare the x terms, I will get negative 7 will be equals to negative 3a plus b. If I were to compare the x terms over here, negative 7 will be negative 3a plus b. Or if you find it hard to visualize, you can also combine this together. The right side, this can be simply simplified to negative 3a plus bx. Okay, and this 7 on the left side here can be compared to this right side, the x term, which has the coefficient of negative 3a plus b. Okay. Therefore, you can now, since I know from this part over here a is equal to 5, negative 7 equals to negative 3 times 5 plus b. B is therefore equals to negative 7 plus 15, and it's equal to 8. And the last one, constant term on the right side. Constant term on right side. I look at the right side now. I find out what terms will expand to give me a constant term. I'll notice it will be a times 2, this will give me a constant, plus b times negative 1 plus c. Okay, so over here on right side it will be 2 times a will give me 2a, then b times negative 1 will be minus b plus c, and therefore I know that this constant on the right side here must be equal to the constant on the left side, which is 3. So therefore, this tells me 3 is equal to 2a minus b plus c. Then I sub in my A, B, C values that I found out earlier. Okay, so over here, this means that 3 is equal to 2 times 5 minus 8 plus C. You can therefore work out C to be equals to 1. And therefore, you can also get the same answers as the left side over here. So you see, if I want to find these values of A, B, C for this question, there are two ways. You can either compare coefficient, or you can either use substitution or elimination. I would prefer to use substitution because I find this easier to think how to, what numbers to sub in rather than comparing coefficients, but it really depends on which one you feel more comfortable with. Okay? Okay. But I think sometimes it may be more efficient. So this comment over here, it really depends on the question. It depends on your skill level as well, whether you are able to spot straight away what terms can multiply together to give you x squared terms, etc. Okay, so this depends on the questions that you get. Okay, so let's look at example 6 now. Example 6, okay. This is similar to example 5 over here. Okay, for example 6, maybe a faster way in this case, what I'll do is to simply use the comparing coefficient. Okay, you can try both methods by yourself. If you want to try, you can pause this video. But over here, maybe I'll use the comparing coefficient to make it faster. 6x cubed plus cx squared minus 17x minus 6. This whole thing, maybe I'll expand this out first so that it's clearer. This one combined together, I should get 3x squared plus 7x plus 2 times ax plus b. Okay, so therefore, over here, find the value of a, b, c. So if we want to compare, we can start by simply comparing coefficient. So meaning, let's say, x cubed term on the right hand side. Then I analyze the right hand side over here. What terms multiplied together will give me an x cubed term? Okay, so over here, you notice that 3x squared must multiply to ax in order to get an x cubed term. So therefore, this means that it should be 3x squared times ax, which will be 3ax squared, x cubed. And therefore, if I were to compare to the left side over here, left side coefficient is 6, right side coefficient of x cubed is 3a. Therefore, 6 equals to 3a, a equals to 2. Okay, another easier way to also compare with is that instead of finding your x squared term, it will be very confusing once you start finding your x squared term. You can straight away find the constant as well. These two here, the only two terms that multiply together to give you a constant in this expansion is 2 times b. So over here, I can also conclude that constant term on right hand side, constant term on the right hand side is simply equals to 2 times b, which is 2b. And by comparison, this means that negative 6 on the left side, the constant term, should be equals to 2b. Therefore, b will be equals to negative 3. And with that, I found the value of a and b. What's left to do now is to simply find the value of c. So to find the value of c, you can simply sub in any answer that is any x value, since this is an identity. What I can simply do is that over here, sub, let's say, x equals to 1. Okay, then I can sub x equals to 1 on the left side. This will be 6 times 1 cubed plus c times 1 square minus 17 times 1 minus 6 equals to, then now the right side, I'll get, over here, sub in 1, I'll get 3 plus 1 times 1 plus 2 times a plus b. Okay, then we work it out step by step. 6 plus c minus 17 minus 6 is equal to, I have 4 times 3, and I know a plus b is 2 minus 3. Okay, simplify my left side. C minus 17 is equal to 12 times 2 minus 3 is negative 1. C is simply equals to negative 12 plus 17. C is therefore equals to 5. And with that, you see, we have solved this much faster. For example 6, using comparing coefficient to find the value of a, b, and c. Okay, but let's say if you can also try the other method. I think this one will take much longer. So if you are able to spot by comparing coefficients, this in this case over here, example 6, this will be a much faster method. Okay. Alright, so let's look at now the last part of this worksheet on division of polynomials. So recall, this is what you learned in primary school. If you should have used long division before. Let's say if I have 14, I divide 14 by 3. Then 4 will be the quotient, 2 will be the remainder. Maybe use another simple example. Let's put numbers. Let's say if I want to divide 8, I divide 8 by 3. Okay, then we remember, recall what is the lowest number you can multiply to 3 to get a number that is less than 8. So we recall, I'll put 2 here. This means 3 times 2 is 6. Then I minus away, remainder is 2. Okay, and therefore I can rewrite that. This means that 8 is equal to 3 times 2, this divisor times quotient, plus the remainder. Okay, this is the remainder. Okay, so this is recalling back to what you have learned before in primary school, but now instead of numbers, you will see polynomials instead. But the steps are still the same generally throughout. Okay, so let's look at example 7. Example 7 over here, I want to divide this by this. So what it means? What does it mean? Okay, I'll first write 3x squared minus 2x plus 5. Okay, I want to divide this by x minus 2. So what to do? I now compare this x over here with this. What number do I need to multiply to x in order to get 3x minus x squared? I need to multiply a 3x. So therefore, I'll write over here 3x. Then I'll multiply this 3x to both terms over here. I will get 3x squared minus 3, then negative 2 times 3x will give me 6x. Then now I minus away. Okay, I minus away, I'm left with 3x squared minus 3x, then negative 2x, then minus negative 6x. It will be negative 2x plus 6x, which will give me 4x plus, then this 5 will go down, plus 5. Okay, then next step, I still have x over 2, x minus 2 as my divisor. What number do I need to multiply to this x minus x over here in order to get this first term here, 4x? I hope you can see it's a plus 4. Then I'll multiply this 4 to this entire divisor over here to write in this portion here. I will get 4x minus 8. Okay, then I put a minus bracket. I'll left with 5 minus negative 8, which will give me 5 plus 8, which is 13. Therefore, remainder is equal to 13. Okay, this is how we use the division algorithm. Okay, so we will continue until the remainder cannot be further divided. You see over here, the remainder is 13. I cannot find any number that multiplies to x to give me 13 anymore. That is a polynomial. That is why I will stop here. Okay, let's look at another example to visualize this. But I think for example 7, you can see that this dividend here is equal to the divisor x minus 2 here times the quotient 3x plus 4 plus the remainder. Okay, which is similar to how we obtain this using numbers, but instead of numbers now, I have polynomials. Okay, let's look at example 8 now. Example 8 over here. Okay, example 8. Find the remainder when this polynomial is divided by this. So let's follow the same steps again. Okay, I have 4x cubed minus 5x plus 5. I want to divide this polynomial here by I want to divide this polynomial here by 2x plus 1. So step 1, I identify what do I need to multiply to 2x in order to get 4x cubed. I hope you can see it's a 2x squared. So but over here I don't have an x squared term, so maybe I'll shift this part here so I can write my x squared term. So we usually write very neatly over here. I leave this column for terms with x cubed, this column here for terms with x squared, this column here for terms with x, and this column here for constants. So over here, I'll multiply by 2x squared I will get 4x cubed. Then this 2x squared will multiply to 1 as well. I will get plus 2x squared. Okay, now I'll subtract this entire thing over here. Okay, so over here you see is this 4x cubed minus 4x cubed, this will disappear. This is a 0, minus away 2x squared. I'm left with negative 2x squared. Then these other terms will bring down, minus 5x plus 5. Then from here, I will continue to check again. This is the remainder now. Can I still divide this by this? And the answer is yes, because I can multiply something to 2x to get negative 2x squared. And I can multiply a negative x. So when I multiply negative x to this divisor over here, I will get negative 2x minus x. Then now I'll minus away this entire thing over here. Okay, I'm left with negative 2x squared minus away negative 2x squared. I miss out x squared here. Okay, and I'm left with nothing. This thing will cancel out. And negative 5x minus away negative x, which means negative 5x plus x will give me minus 4x. And this 5 will bring down plus 5. Then last step, I check again. Can I still continue from here? 2x, can I multiply any number to 2x to get negative 4x? And the answer is yes. I can multiply a negative 2. If I multiply negative 2 here to the divisor, I will get negative 4x minus 2. And now I subtract this away. I'm left with, this thing will cancel out. I'm left with 5 minus negative 2. And this will be 5 plus 2. I'll get 7. Therefore, over here, remainder is equal to 7. Okay, and this is the answer for example 8. Okay, so over here, so if you actually notice, right, if you still remember the term called degree, we went through the term degree earlier. Degree means the highest power of x in your polynomial. So if your divisor, let's say if your divisor here, the degree is 1, do you notice that the remainder, the degree is always less than the divisor? Why is it like that? I hope you can rationalize and think. If your divisor, the degree is 1, this means that whenever I have x over here, I can still continue dividing. So therefore, this means that the remainder here, your degree must always be less than the divisor for your division algorithm to work. Okay, so over here, this means that if your degree of the divisor is 2, the degree of the remainder must be less than the degree of the divisor. It can only be 1 or 0. Okay, it must be strictly less than 2. Okay. Alright, so now let's look at the last one over here, example 9. Okay, express this polynomial into this form over here, quotient plus remainder, which means that this must be your divisor. Okay, you can label this as our divisor, which means that I want to divide, let's write down, I want to divide 6x power 4 minus 8x power 3 plus 3x squared plus 4x minus 1. I want to divide this by, my divisor will be 2x squared minus 4x plus 3. Okay, so therefore let's work out step by step. Okay, over here, I check. This divisor here, what do I need to multiply to cancel out the first term? I hope you can see that I should multiply from 2 to multiply a 3 to get 6. And this x squared, multiply x squared to get x power 4. So I should multiply a 3x power 2. Then this thing here multiply to this. Okay, I will get 6x power 4 minus 12x cubed plus 3x squared. Okay, now match ready, then I can now write minus away. Then what am I left with over here? Negative 8x cubed minus away negative 12x cubed. I have 4x cubed. Then this thing here, 3x squared minus away 3x squared, left with nothing. Is it left with nothing? Let me check again. 3 times 3. Sorry, this one should be, careless mistake. This one should be 3x squared times 3, which should be 9. 9x squared, okay? 9x squared. Okay, therefore, if we were to subtract, 3x squared minus away 9x squared will give me minus 6x squared. Then we can bring down the remaining over here. Plus 4x minus 1. Next step, I check now over here the remainder here. Can I still divide by the divisor? And the answer is yes. Because 2x squared, what can I multiply to 2x squared to get 4x cubed? The answer is plus 2x. Okay, so if I multiply 2x to this entire divisor here, I will get 4x cubed minus 8x squared plus 6x. Then now I subtract everything away. I will get 8x squared minus 6x. I'll get 2x squared. 4x minus 6x, I have minus 2x. Then minus 1 will bring down minus 1. Okay, and now I check again. Divisor, this is the remainder here. Divisor, can I still multiply anything to get 2x squared? And the answer is yes, I can multiply a 1, okay, in order to get 2x squared. Therefore, this 1 multiplied to the entire divisor here, I will get 2x squared minus 4x plus 3. Then now I subtract away, I will get negative 2x minus negative 4x, I will get 2x. Then negative 1 minus 3 is minus 4. Okay, therefore over here we can see that this is the remainder. Let me label this. This is your remainder. The top one here, this is your quotient. So therefore we learned in the previous form that I can express any dividend here by the divisor times quotient plus remainder, which means that to answer the question, therefore qx, which is the quotient, is equal to 3x squared plus 2x plus 1, and the remainder rx is equal to 2x minus 4. Okay, and this is the answer to example 9. Okay, so if you are okay now, please go back and try the practice questions over here before we practice in class. Okay, so this will be the end of this